reaction methods of carboxylic acids. We have seen physical properties of carboxylic acids, and now we are into chemical properties. In chemical properties, first reactions, or the first set of reactions is reactions involving cleavage of OH bond. So we are discussing in the last class about this reactions. That is, cleavage of OH bond is nothing but we are talking about the acidic nature. Discussing about the acidic nature. And in the last class we have discussed about reaction with metals, sodium metal or alkali metals, and also we have seen some reaction with sodium hydroxide and sodium bisulfite. Okay, and we have seen that if carboxylic acid OH bond is cleaved, then you will get carboxylate ion. This carboxylate ion we have also written, like there is possibility of resonance of this kind, conjugation, and finally we have written like this, showing both the oxygens with partial double bond character like this and negative charge. This is resonance hybrid of the carboxylate ion. Okay, so as we have discussed earlier, if electron withdrawing group is attached to the carboxylic acid, then it stabilizes, or it provides stability to the carboxylate ion, therefore increases the acidic nature, or acid strength is increased. Okay, if electron releasing group, this is electron withdrawing group. Okay, if electron releasing group is present, then it destabilizes the carboxylate ion, therefore decreasing the acidic nature or acidic strength. So likewise, in the last class we have seen one example of benzoic acids like this. Benzoic acid containing methoxy group, normal benzoic acid, benzoic acid, and benzoic acid containing electron withdrawing group. If you consider these things, which is more acidic? Electron withdrawing group containing nitro group containing benzoic acid is more acidic than normal benzoic acid than methoxybenzoic acid. So likewise, we'll see some few examples of the different kinds of benzoic acids and their acidic strengths, or some other different acids also. Okay, we'll see the examples. Okay, now some examples. Trifluoroacetic acid compared to trichloroacetic acid. Dichloroacetic acid. If you compare the acidic strengths of these three compounds, fluorine is more electronegative. So as the electronegative character increases, the electron withdrawing nature increases. Means CF3 will withdraw a lot of electrons from acidic, this one, COOH group. So it acts as a strong electron withdrawing group. So as we have discussed, if electron withdrawing group is strongest electron withdrawing group, then the strength also, acid strength also will be strongest. So CF3 is much more stronger electron withdrawing in nature than CCl3, than compared to dichloro, than compared to chloro, you can say. Okay, so which will be more acidic in this case? Means trifluoroacetic acid will be more acidic because it is more electron withdrawing nature because of 3 electronegative fluorine atoms. Then among chlorine, trichloro and dichloro, trichloro is more electron withdrawing in nature. So it is more acidic than dichloro. So understood? So more the number of halogen atoms and more the electronegativity of the halogen atoms, more will be the electron withdrawing nature and more will be the acidic character. Example 2. Let us take a nitro and cyanoacetic acid. Nitro and cyanoacetic acid. Nitro group is stronger electron withdrawing group compared to the cyanide group. So nitroacetic acid is stronger acid than cyanoacetic acid. Okay. Similarly, fluoroacetic acid, chloroacetic acid, and bromoacetic acid. If you compare this, as the electronegative character is more, the electron withdrawing nature will be more. So fluorine is more electronegative than chloro than bromo. Then you can also write here hydro. So it is more acidic. Fluoro is more acidic in nature. Then compared to chloro compound. Then compared to bromo. Then compared to hydroacetic acid. Okay. Similarly, comparison is between formic acid and benzoic acid. Formic acid and benzoic acid. Formic acid is more acidic than benzoic acid. Okay? And benzoic acid is more acidic than normal acetic acid. Normal acetic acid. So what is happening here? In formic acid, there is no electron releasing or there is no electron withdrawing group. Directly formate ion will be produced. So formate ion does not consist of any electron releasing group or any electron withdrawing group. So this is more acidic than phenyl, the benzoic acid. Why? Because in benzoic acid what happens? Phenyl group with COOH, if you take like this, what happens is COOH group itself is deactivating group. So there can be shifting of electron taking place like this. So phenyl group can show their resonance plus R effect or plus M effect. Due to that, benzoate will become little bit destabilized compared to formate ion. Benzoate ion, due to that resonance plus R effect or plus M effect, what will happen? It becomes a little bit destabilized. Stability is attained in terms of resonating structures. So that's why benzoic acid is more stable. Benzoic acid is more acidic compared to acetic acid. Now acetic acid, why it is less? Because in acetic acid this is plus I effect. Alkyl group show plus I effect. So it is electron releasing, but there is no conjugation and no resonating structures. But in this case, even though it is electron releasing, phenyl group can be plus R or plus M effect. And resonating structures will provide more stability to benzoic ion compared to acetate ion. That's why formic acid is more acidic than benzoic acid. Benzoic acid is more acidic than acetic acid in this case. Now if you compare benzoic acid with like this, means 2-phenyl acetic acid and benzoic acid. Now benzoic acid will be more acidic compared to 2-phenyl acetic acid. Why? Because here in this case resonating structures are more. In this case it will show plus I effect. Okay, because there is a resonance is not possible between CO and phenyl. So due to resonance it will be more stable, more acidic. Here only plus I effect, it will be less acidic. Okay, understood? So like this, as the CH2 groups are increasing, plus I effect increases and carboxylate ion stability decreases. So acidic nature decreases. Or another example, let us take comparison between acetic acid strength or ethanoic acid strength with ethanoic acid strength with propanoic acid. Propanoic acid strength with butanoic acid. So as the alkyl part is increasing, what is happening? Plus I effect increases. So acidic nature decreases. So that is about the acidic nature, acidic strength of the carboxylic acids. Okay. Next topic, reactions involving cleavage of CO bond, okay, or COH bond, you can say COH bond. Now in this, first we are going to see about anhydrides formation. Anhydride formation. Now in anhydride formation, any carboxylic acid, you take either mixture or same carboxylic acid. If you are aiding with any mineral acid or with dehydrating agents, if you are treating, then water molecule is lost from two molecules of acid and it produces anhydrides, that is R C double bond O OH plus R C double bond O OH, two molecules are taken acids. Treating with some mineral acid, it may be H2SO4HCl, any strong concentrated acid, or else you can also use the dehydrating agents P2O5. Then right here, or you can use. What will happen is, one molecule of water is lost. Means in this reaction, one H bond and one OH bond is cleaved. One H bond and one OH bond is cleaved. So let us assume like this, one water molecule is lost. So what happens here, this C and this C gets linked by this O. So R C double bond O, this R with C double bond O, this carbon linked to this O. So I will write here O. Then after O again C double bond O R. Again C double bond O R. This is acid anhydride. It is acid anhydride. Okay, so water is removed, so I will write here minus H2O. Water is removed. P2O5, dehydrating agent. Dehydration reaction is carried out by concentrated sulfuric acid also, or P2O5 also, that everyone knows, right? Then let us see some example how this is happening. Let us take acetic acid only, two molecules of acetic acid. This is known as acetic acid molecule. Okay, now I have taken acetic acid. Now what is happening? Removal of water. One H from one acid. Like this. So on treating with P2O5 minus water. So what I'll write? CH3 C double bond O C double bond O CH3. It is what? Acetic anhydride. Acetic anhydride. It is also sometimes represented like this. It is equivalently represented like CH3 CO. Two CH3s are there, two COs are there. So let us take CH3CO taken twice and one oxygen extra. That extra oxygen I am writing outside. So this group taken twice, one oxygen outside. So anhydrides are represented in that way. Okay, anhydrides are represented like acetic anhydride. Similarly, you can take a benzoic acid also. Benzoic acid, concentrated H2SO4 on heating loses water. So what will happen? Benzoic anhydride is formed. So I will write like this: C6H5CO taken twice O, benzoic anhydride. Okay, so this is about anhydride formation. Next reaction we'll see.